So I know this is supposed to be a CEU on stroke, and that's okay, but you can't just talk about stroke because all neurologic diseases and injuries are the same. They do the same destructive sequence, and we're going to do the same rebuild sequence. And this is going to be stuff you haven't probably heard before, but we're going to cover all of those. And the CEU that they gave me to give, or the standard CEU, is pretty bad. So I asked, can I just do my own thing? And they said, fine, let's do that. And it'll be a lot more educational than this. So this is what I got to do in CEU. And I really like this because, you know, see this little guy over the translucent head with the brain? And I showed it to my son, Chris, and he said, you know, my 9-year-old, this is on her level, and actually not even on her level, because she comes up to me and says, hey, Pop, do you know about phosphorylation of ADP? So this wouldn't even, that generation knows so much more than we give them credit for, but this is way too basic for us. A brain attack, give me a break. So I said, we're going to modify this a lot. And here's another slide from, this is Myths and Facts. And it's produced by the American Stroke Association. And it's the same old garbage that you always hear. 80% of the strokes are preventable. Any sign of stroke, call 911 immediately. Stroke can happen anyone, anytime. It's a brain attack. And it's a lifelong process. And here's the thing that always troubles me. You always get these statistics. 7 million stroke survivors in the US is the leading cause of death. When are you going to use that in your clinical practice? Are you going to just talk to people about, did you know there's 7 million people with strokes? Or if you're in church and you're bored with the sermon and you want to talk about something, so you lean over to them, hey, guess what? I got a fact. It's 7 million people have strokes. Really? They do? So this is just a waste of space. So I'm going to talk about, oh, and here's SpongeBob. So now we've got, it's so puerile that it's not even worth talking about except to show you how ridiculous it is. And you'll notice that in this there is cholesterol. Everywhere there's cholesterol. And I'll show you why that's ridiculous also. So we're going to talk about all of that, things that you've heard all your life about strokes. It's so outmoded and outdated now with the science that we have. So you've heard about the be fast. And that's also ridiculous because if grandma comes in the kitchen and she puts the cat in the refrigerator, you're going to know something's wrong with this woman. You're calling 911. You're not going to say, smile at me. Let's see if your balance is good. Can you move your arms? No, you're going to call 911 and get the cat out of the fridge. So, and here's another, this is the last slide I'm going to show you about. This is so ridiculous. So this is what you're going to do. You're going to walk in the park. And you're going to, CBD oil for stroke recovery. Oh, you're going to get your Oculus out, and that's going to help you. And you're going to do some yoga. And I don't know what this is. What, did they go to the dentist also? So I had to replace this whole thing. So let's talk about stroke. So here's what we know. We have nothing to offer in stroke. We have therapies. We have PT and OT and speech. And yet there's a lot to do to know about that. Task repetition, you make new synapses, and yeah, that's great. You know, it's like practicing the piano. At first it's a labor, and then eventually the synapses form and you can just rattle it off. And so that is the only thing we've ever really done in rehab that has potential to help people. But there's no neuroscience involved because we think, okay, a stroke is a stroke. And it's nothing like the next stroke. So you see a stroke, you've seen a stroke. And what we want to know is, what can we study that is consistent across all strokes and all brain injuries? And that's what I'm going to show you today. But because of that, PM&R probably has the worst research out there because we have got nothing to look at and no absolutes. So, and part of that comes from the fact that for 100 years, since Ramon y Cajal back in the early 1900s, we thought that the brain is unique. He said the brain's unique, it can't repair itself. And it's stupid because that's the only organ in our bodies that can't repair itself. So now we know that's not true, and I'll show you why. But so back in the late 70s, I was working with doing research on the brain connections that control the cardiovascular system. And so I was mapping the brain on neuropharmacology and some of the pathways involved. And at that time, I was using things like coenzyme Q10 and acetylcarnitine to get the mitochondria in these cells to crank up and start working better, and to see if I can control some of those reflexes. And it was great. So then I went to residency after med school, and I started working in 1990. I opened a hospital for Tony in Clear Lake. It's Clear Lake Rehab Hospital over there. And it was the first rehab hospital between Houston and Galveston. And at the time, the neurologist in the town says, "We don't need rehab, we got nursing homes here." So slowly we began to educate them that there is such a thing as rehab and we can actually do something for them. So that's been a good leap. We're now, 30 years past that. And at the time I thought, okay, I got these strokes. Well, how am I going to make them better? Because they're not getting better. We got no real treatment for strokes. We still don't have a treatment for strokes, by the way. And I started using the CoQ10 and carnitine and alpha-lipoic acid, things that make the mitochondria crank up. And I thought, okay, in the stroke you have a dead part of the brain in the middle, but at the margins you have these borderline cells that are still kind of gasping for air. Can we come back online, or are we going to go ahead and die like my neighbor is? And so what we want to do is try to keep them alive. So if you keep that neuron alive, you can maybe resurrect the brain and at least some synapses there. So CoQ10, if you don't know this, is a chemical in your mitochondria that converts oxygen and sugar to glucose. So in every brain cell you've got 1,000 mitochondria, and they're all cranking full scale to try to make the energy required for the brain. You got the same in the heart, the kidney, all the big organs. They have tons of mitochondria. If you can save the mitochondria, you can save the organ. If you lose the mitochondria, you're going to lose brain cells, and you're going to lose kidneys and hearts and everything else. So the idea is to try to preserve them. So you pump them full of CoQ10. Now you can say, oh, the brain cell is going, okay, I can make it now. I think, I got a little energy, a little shot in the arm, I can do this. And the other thing I used was acetylcarnitine. Acetylcarnitine is how you make energy from fat in all your mitochondria. So you're constantly flipping back and forth between sugar and oxygen and fat. And it's really important in the brain because you got an ischemic spot and you've got a brain that's gasping for air and it's not able to use oxygen and sugar. So it has to switch gears. So our brain cells and all our cells are just like Priuses. You can flip back and forth every millisecond. You're going back and forth between oxygen and fat. And so I said, if we're going to salvage some of these brain cells, we're going to have to pump them full of acetylcarnitine and see if we can at least save the margins, the borders of this ischemic zone in the brain. And it worked pretty well. So the first 5 or 10 years, I worked with just mostly that, and we'll talk about that in a minute and how that works. But in 1992, this guy from New Mexico thought he saw stem cells in the brain. He was doing electromicrographs, and he had a seminar in New Mexico, and everybody attended from around the country. And he showed these slides, and he said, these are stem cells. And everybody goes, ooh, wow, that's kind of cool. But there's this one attendee that said, I don't think those are stem cells. And this is a guy that has made his entire career for 30 years of saying the brain can't regenerate, just like 100 years ago. So he stands up and he says, well, doctor, they may look like stem cells in New Mexico, but they don't look like stem cells in New Haven. And of course that professor, this is a big name in brain, and so he kind of slinks off the stage, and that was the end of that. But I read this study and I thought, that's cool. Now I know if I can tweak those stem cells to turn into brain, then we ought to be able to not only protect the brain with CoQ10 and all that biochemistry, but we can also make new cells. We can make those stem cells morph into neurons. So for the next 30 years, all I've been doing is working on what makes that happen. So every paper that came out, whether it was an animal paper or whether it was in vitro in a petri dish, I looked at all those papers to try to figure out what are they doing to stimulate that stem cell to become a neuron. And so that's what I did. So I started with the mitochondria and then generated this protocol with that. And after I read the New Mexico study, I thought, hey, this is really pretty cool. Let's dig into that. So the next 30 years, all I did was try to figure out what can make a stem cell morph into brain. And that's where I've been for all this time. So the first step is to, and it's great because again, Ms. Atano let me do whatever I wanted to do, which is absolutely marvelous. And so the first step was to increase the mitochondrial number. How can I make more mitochondria in every cell? Because that's the factory I need to generate energy from. And we know that all the mitochondria are the most compromised part in any brain injury, any dementia, anything. So if I can preserve those, I ought to be able to preserve the cell. And then secondarily, I wanted to activate that neural stem cell maturation into new brain. And we'll talk about this sigma-1 receptor and how that works. That's amazing stuff. So let me give you a case. This is a Marine. You can read for yourself. He was driving along at 100 miles an hour, and he had a wreck. He got ejected from the vehicle, and they admitted him. This is a PAM hospital in North Carolina, and of course he was a wild man. And if you've had acute TBIs, you know exactly what I'm talking about. Choking the nurses and running naked through the halls and stuff. And I do that, but my wife said I can't do that anymore. So this guy was a real disaster. So they call me and they said, I've got this guy that's running through the halls and choking the nurses. So I started him on this protocol. He has a PEG tube, he has a trach, and within 24 hours, he was a completely different person. So within 24 hours, he started talking and interacting. Well, they pulled his trach. He pulled his trach. So this is what I got back from the attending. And she sends me his email and he says, I started this protocol on Isaac first thing in the morning, and by the afternoon he was calm, talking, following commands. Have you ever seen this big a change in a short period of time with your TBI patients at your hospital? It's a miracle. God is good. And yes, that's what you see. So what happened to this patient then after that? Well, he's still taking this compound, and we'll talk about that in a second. And then later he goes home and we get this note from his mom, and he says, Isaac is doing great. His recovery continues to amaze us. It's truly amazing. And so she writes this wonderful note, how grateful she is to the hospital and everybody. And she puts this Bible verse down, Proverbs 3, 5, and 6. And that's trust in the Lord with all your heart, and don't lean to your own understanding, and he'll make the path straight. He'll figure it out. And there's also another part that she didn't put in there, but it says vote Republican. So that's in there. It's scriptural. All right. So first you've got to stop this destructive cascade. You got to understand that, because instead of doing that be fast garbage, what you want to know is, what can I do now for grandma? Besides getting the cat out of the fridge, what can I do now to stop this destructive sequence? Because what happens is the first cell dies, it's happy over here, one cell gets injured, and it releases stuff. It releases free radicals. All its internal contents get out into the brain milieu, and it destroys the one next to it. And it goes like a bomb. And that's how a patient will come in the ER, and they'll have a weak arm. And they'll CAT scan his head, and everything's fine. Oh, yeah, you're going to go back and see your neurologist when you get out of here. Well, 3 months later, they're going to see the neurologist. But what happens, they go home, 48 hours later, the patient is paralyzed on that side. And what happens is, you've got this ongoing bomb of destruction that's continuing on. And by the time it really manifests as a total hemiparesis, then it's really too late to do much of anything. But if you don't understand this destructive sequence and what's happening, then you can't stop it. And they don't have anything for that. And that's scary. So, and I didn't mean to put crap up there. I know it's a bad word, so apologize for that. My mom's upset. She's in heaven, but she's upset with me. All right, so here's the injury cascade. Oxidation, when those membranes leak, they leak free radicals. They also leak the neurotoxins. Neurotoxins are not neurotoxins when they're inside the cell. Glutamate is your excitatory neurotransmitter. It makes everything work. But when it escapes, it kills the cell next to it. So you have this surge of excitotoxic neurotransmitters. So that's going to kill the cell. And then the inflammation kicks in. And the blood-brain barrier wakes up and opens up. And the immune cells from the periphery, from the vascular tree, come in and they start attacking the brain because something's wrong. It's inflamed. We got to attack. So you get this destruction from all corners. You got to stop all of this. Am I too passionate? Am I getting too into it? Okay. So the killer of the brain is free radicals, excitotoxic glutamate, and inflammation. We got to stop all of that. So here's what I did. I started out with how do you stop the free radical release? And you got to scavenge it. So I don't know if you can see this in the back, but this first one is PQQ. And what it does is it scavenges all these free radicals. Vitamin K2 does the same thing. Vitamin D does the same thing. We talked about acetylcarnitine. It also prevents these electron leakage from the dead mitochondria, and CoQ10 and melatonin. The melatonin is not for sleep. It does all this fun stuff, and we're not going to go into it today. So the next thing is we wanted to suppress the neurotoxins. But what a surprise. Every one of these things does that too. So I'm hitting 2 of the big 3 that we want to stop in the process of this destructive sequence. And then we want to stop these pro-inflammatory. And guess what? The same stuff does that. So in just this one compound of things, I'm able to arrest this destructive sequence. So let's say you take the cat out of the fridge, and you take grandma and you give her a bunch of CoQ10 and carnitine instead of that stupid Bayer aspirin, and then you call 911 and say, grandma's had a stroke. And then you go from there. Can you arrest this destructive sequence? And yes, you can arrest it. We're not doing that. We should be doing that. This is just pure science. All right. So here's PQQ. PQQ is this weird thing that's a vitamin thing, but it makes new mitochondria. So you can see nerve growth factor increases dramatically when you put PQQ on. So I need more nerve growth factor to make new cells. So that's part of that whole protocol also. So with that, I've increased mitochondrial number and how they work. I've stopped the destructive sequence. But now, I want to see if I can measure that. Let's prove that I've actually done something. There's a sigma-1 receptor that's in all the cells, and this is one of the things that came out of that 30 years of work. The sigma-1 receptor, if you bind it up with particular neurotransmitters, you can actually cause the stem cells to turn into neurons. So that's the next phase. So here's a patient that I think was most fascinating. This is a young kid, 28 years old. He worked for an oil and gas company in Denver. He's walking down the street, and I don't know if you've ever heard of the knockout game, but it was really popular back 20 or 30 years ago. And they would come and they would hit you right at the base of the skull, and of course, you're immediately paralyzed. Everything goes limp. So you hit the ground, and and people were dying from that. In New York, there were a lot of cases that happened. So this kid had the same problem. He hit the back of his head, and you can see he has a bleed back in the occipital area, and then a contre-coup in the front. So the brain slammed into the concrete and slammed back into the front part of the skull. That's coup contre coup, and you all know about that. So he has a brain bleed there, and you can see how it evolved over time. It's still matured. And so he got better. he got functional, but he lived in this fog, and this happened in 2012. For 6 years, he stayed in this fog. And he quit his job, and he floundered around for a while, and then he found me, and he said, can we do anything for this? And I said, well, we can try. Let's try this out. So we put him on this compound that I talked about, PQQ and everything, but it also has the things that drive the sigma-1 receptors as well. And we had used initially individual pills. And of course, nobody likes to take pills. And Christopher and I were down in South America. We were working in a little clinic in Cartagena. And we were trying to get these little autistic kids to take this to see if it would work. And we were walking along the seawall, and I was saying, well, how are we going to get these kids to take this stuff? He says, well, make it into a drink mix. So we came back, we bought a bunch of lab stuff, with mixers and everything, and we started putting it together. And it was pretty god-awful tasting. So but we were able to make this drink mix, and we were able to carry on with playing with some of these autistic kids. And it was really amazing. Some of them really got better. Some of them really got worse. And since I was paying for this whole thing myself, I thought, I can't keep doing this, but we'll get back to it someday. But at least we came up with this drink mix that has all this stuff in it. And that's what we use. And that's what we used in Isaac. He had a peg tube, great. And we pump it right down his peg tube. We got it finally to where it tastes good. This latest iteration that you have in your bag, you can taste it. It kind of tastes like Tang. Some people mix it with milk, some people mix it with water. It's not really bad tasting, but it's got 17 things in there that all either stop the destructive cascade or they make new brain. All right? So, how do we know that that really happened? Did it really make new brain? Well, I ran into these guys in Denver, and one of them is named David Oakley. He's won the Nobel Prize for works on neutrinos. And so we learned a little bit about astrophysics from him. But he and his partner, David Jaffe, who is also famous for other stuff, and I'll go into that some other time, but they said we can make this little compact unit, it's just a little laptop, and we can make an EEG thing with it. But this output can put out something called coherence. And everybody on the planet knows that coherence is a measure of connectivity. It's not even a debate. So we thought, okay, let's give this guy this compound and let's see if it helps. And then we'll redo it. So you can see this top line. Can you see my little pointer? I don't know if you can see that. But these are the 4 wavelengths of an EEG. Every dot is an electrode inside this little helmet that we make out of the guy that invented Crocs. He made the helmet for him. And so these electrodes are contacted the brain in specific parts. So this is the frontal part of the brain, and this is the posterior left and right. So you have these 4 wavelengths, and the analysis that it does a Fourier analysis. It decides what's connected to what. And so every line is a connection between these different electrodes. And you can see initially, he didn't have a hell of a lot going on here. After 30 days, we redid it, and you can see all these red lines. Those are new connections. And they're new connections at the probability less than 0.05. They are significant connections. And look at where they are. Do you remember where his lesion was? In the occipital, all the way up to the frontal, all this frontal stuff coming back online, all that edema that was in the occipital lobe. We've got all these new connectivities. So every wavelength, every part of his brain started firing up. So we knew, so we've got something happening in his brain, and we can now prove it. So he made a full recovery in 3 months, and this is 6 years post-injury. No one has ever shown that before, and no one's ever been able to prove that we got new connections in the brain. And that's why this is pretty exciting. And that's why I threw SpongeBob out. I said, you don't need SpongeBob. You need this stuff in this CEU. So that's pretty exciting stuff. So with this compound, and Tony lets me use it in the hospitals, we're using it in other hospitals too in the country, and we've made some amazing gains. And that's why we really want to start this nationwide hospital study group that hopefully we can get a standardized thing, and we can actually get some decent research out of PM&R. So here's how it works. We talked about the mitochondria. Now we're going to talk about this sigma-1 receptor. Are you guys interested, or you want to go play pickleball? just show of hands. All right, so let me tell you about this sigma-1 receptor. It lives right between the mitochondria, which is right here, and this endoplasmic reticulum. And you don't have to know this, but there's this interface between these two areas. And if we can stimulate that sigma-1, all these proteins start being generated here that make new cells. And we also know that it's going to stop the free radicals, excitotoxic neurotransmitters. So you didn't have time to read that, and I'm telling you, that's what it does. So it's on top of what we're getting out of all of those chemicals I told you before. Stop the free radicals and stop the neurotoxins, and you stop the inflammation. But here's something that you don't know, and this, you're not going to be told this, but I'm going to tell you, and you can tell everybody that Dr. Clark, the brilliant Dr. Clark, is telling you that if you don't have cholesterol, you can't get this sigma-1 to work. What's the first thing they do to a stroke patient in the hospital? Does anybody know? Statin. They put you on a statin. The very thing we desperately need to make new cells, membranes, everything. So the sigma-1 cannot be switched on if it doesn't access cholesterol. So here's what cholesterol does. I don't know if you've ever seen this, but this is from a paper I wrote back in 2012. And you can see where the statin drug blocks this sequence of events. And yeah, you get a decrease in cholesterol, and that's the only thing anybody ever cares about. Oh, cholesterol down below 200, you're going to live forever. So, but if you ask any of those doctors what mevalonate is, or FPP or Hem-A, they're not going to have a clue. And look what you're losing here. You're losing everything that comes from cholesterol. Cell membranes, the myelin sheath around the nerves, on the axon that you're desperately trying to remake, and all this stuff inside the cells that also has a membrane. And you're losing all your steroid hormones, vitamin D, estradiol, testosterone, cortisol. We'll talk about that in a second. And you're losing CoQ10. So you put patients on statin drug, they get muscle cramps, and you're gonna have to change, we're gonna change you to a different statin. So they do that, and they still have muscle cramps, they quit taking it. And the reason they have muscle cramps is because the mitochondria are starving for energy. If you load them up with CoQ10, you can get rid of the cramps. This is just straight science, but nobody seems to know that. But more important than that is these Rho proteins, Rho and RAS proteins. And that comes from these things that nobody knows what they do, but they generate these proteins. These proteins take your DNA from old cells, they copy it and make a new cell. So if you stop that, then you're stopping your regeneration capability. So everything about this statin has absolutely no basis in any science whatsoever. And if you look at the data, there's not a lot of benefit from it anyway. And most of the world is now kind of getting away from statins. They're starting to look at inflammatory markers like high sensitivity C-reactive protein and those. So finally, maybe there's some sanity, but it'll take 20 years before you change the doctor's mind. So I'm trying to get you informed now. When you hear that, you go, genius, Dr. Clark said. All right, so, and this is from that old CME PowerPoint. This is really funny because they're still putting this out there for CME. And look at this. If you lower the amount of cholesterol in your diet, you can prevent strokes. We have thrown that out in the 1980s. Now we're eating shrimp and egg yolks again. We don't even do that anymore. And yet they're still publishing that for you guys to take home and learn. And look, you guys are all drinking alcohol. Look at what you're doing to yourself. All right, so you need cholesterol. Are you following me? Is this too much for you guys? All right, you can tell me to stop anytime. All right, this is cholesterol, and it has to do something. All of your hormones come from pregnenolone, which comes from cholesterol. Pregnenolone is the mother hormone. That is in my compound. That and DHEA, because DHEA and pregnenolone drive the sigma-1. So does estrogen. So does progesterone. So does testosterone, DHEA, cortisol. All of these things make that sigma-1 fire up and move the stem cells into neurons. Is that exciting? You should be excited. Come on. So cholesterol activates the sigma-1. You get all these anti-inflammatories like we talked about a minute ago. And this is the sequence of events. Neurosteroids, those things I just talked about, pregnenolone, DHEA, estrogen, progesterone, testosterone, everybody that said those cause strokes, they're completely wrong, because that's the thing that makes brain. So the sigma-1 gears up and it does these things. It drives brain-derived neurotropic factor and nerve growth factor, critical in making new brain. It stops the GABA inhibition of stem cells, which, and I'll talk about that in a second. It increases glutamate inside the cell, not the neurotoxic stuff outside, but that's your excitatory neurotransmitter. And it increases this stuff called nicotinic acetylcholine, and it increases dopamine level. What do you know about dopamine? What disease process is dopamine critical in? Parkinson's, thank you. One voice out of what, 40-something? Come on. All right, so all we got to do is give neurosteroids, drive the sigma-1, you can increase dopamine, and you can increase nicotinic acetylcholine. And why is nicotinic acetylcholine important? Because when you stimulate the sigma-1 receptor with these neurosteroids that we use in this compound, it makes nicotinic acetylcholine, and acetylcholine then turns around, and GABA is normally an inhibitory neurotransmitter that keeps these baby stem cells in their little nursery to keep them quiet and not making any noise. But if you can stop that GABA inhibition of these stem cells, then they start maturing. And actually, GABA turns into an excitatory neurotransmitter that nobody seems to know, and it stimulates the growth of these babies into teenagers. And then glutamate, which is that excitatory neurotransmitter, drives these teenagers into mature neurons. On top of it, so now I got new neurons. All I had to do is put this stuff back in. The brain knows what to do, we just got to give it what it needs. It also, just this last three, we're talking about Parkinson's. We increase dopamine activity. It also, nicotinic acetylcholine prevents the death of dopamine neurons. So what happens in Parkinson's is, yeah, you can give L-Dopa, you can give Citamat, and that's great because you can accommodate this loss of function because you're giving the dopamine orally. But you haven't stopped the process. These cells are dying in the striatum, and we've got to stop the death process. All right, so with this, all we have to do to try to reverse and at least hold Parkinson's at bay is to start this process. It slows the Parkinson's progression. These are studies. I didn't make this stuff up. These are studies. So it slows the Parkinson's progression, and it keeps those neurons surviving, and it also is going to help protect from Alzheimer's. We know that Alzheimer's patients do better if they smoke or chew, and date girls that do. And so I also use this stuff called acetylcarnitine. We talked about that, right? Acetylcarnitine is that thing that makes fat burn in the mitochondria. It's Alcar. Alcar is how you make acetylcholine in your cells. So if you don't have acetylcarnitine, you can't make acetylcholine, which is what we're trying to get to stimulate the stem cell maturation into neurons. So this is simple stuff. You just got to go out and buy some acetylcarnitine. You can do a lot of this yourself. It's just that everything else is what I had to do for a full neuro patient, and without having to get 1,000 pills in them. So This, as I said before, this happens right there at the endoplasmic reticulum mitochondrial junction, and the mitochondria talks to this endoplasmic reticulum at that MAM interface. So these are the neuroactive steroids I'm talking about. Every one of these will drive that sigma-1, and it'll drive it in specific ways. Like I said, progesterone will turn the stem cell into an oligodendrocyte, a myelin maker. Pregnenolone, of course, is the mother. Testosterone will do the same thing. Estrogen, everybody tells you if you're on estrogen, you're going to have a stroke. And I get blamed for this all the time. And the patient goes to the hospital, and they've been on hormone replacement, and they say, oh, probably Clark made this happen, put him on HRT. But no, actually that's not true, because we know that from this study, I'm going back, let me jump back. I'll talk about that in a second. So what happens then, we'll review this. The GABA stimulates, if we release these stem cells from GABA inhibition, it starts them maturing and differentiating. Then the neurosteroids binding to the sigma-1 arrests that GABA inhibition and allows the stem cells to mature into neurons. And then they integrate into the network, making the new connections. You saw proof that we are making new connectivity in the brain. And that's got to be exciting, because nobody's ever been able to do this. And also we know that in Alzheimer's, this APOE gene E4 gene, it stopped the GABA from doing that. So maybe that's one of the mechanisms about Alzheimer's. Maybe it stops the GABA from changing the stem cells into brain. That's just an interesting aside. But look, I'm not the only one that says that. If you go to all these publications, neuroactive steroids such as DHEA and pregnenolone all activate the receptor. Therapeutic potential in the treatment of various neurodegenerative disorders from these sigma-1 receptors and neurosteroids. Sigma-1 holds promise in application as a potential therapeutic target for treating neuropathologic diseases. And if you go to the almighty wisdom of knowledge, the Wikipedia, they will tell you the exact same thing. And we know we can count on that. All right, so what I'm trying to do is I'm trying to get this brain cell to do this. I'm trying to get it to grow these axons out and bind to another neuron. It's looking for a connection. Where is it? It's not like some guy looking for a hot chick at the bar at midnight. There's a tractor beam that's drawing that axon over to it, and we've got to see if we can't make it happen. So this is also from that old stroke PowerPoint, and this is where I was going with that. Look at this. Hormone therapies, including estrogen, increases the risk of stroke. We have stayed on that forever. And people say you got to don't take hormone replacement. I know you're in menopause, but you're going to have a stroke. And it turns out that they did a study that came out about 3 weeks ago. 10 million senior Medicare women, and they studied it between 2007 and 2020. And they looked at all of these things, all different cancers and cardiovascular disease and dementia. And look at this. This is what they didn't tell you. Remember when they came on the morning shows back in the early 2000s, oh man, you can be on hormones for 5 years, but after 5 years you better get off hormones. They had no data to support that, none whatsoever. They made that up. So it turns out that if you stay on this stuff, you have a significant risk reduction in mortality of 19% from all causes. A decrease in breast cancer of 16%, lung cancer of 13%, colorectal cancer of 12%, congestive heart failure of 5%. I mean, just DVTs, 3%, atrial fib, 4%, myocardial infarction, 11%, dementia, 2%. Actually, it's really higher than that. Low dose, so endometrial cancer, 45% decrease in incidence. Ovarian cancer, they didn't tell you that. So this is pretty fresh off the press. You can't ask for a bigger sample size than 10 million senior Medicare patients studied for 14 years. So you got to take that home. Just take that home, because that's important information. And you realize how you were led astray. So this is this neurocognitive supplement that we've developed over the decades. And And it really finds its basis in neuroscience. It's very well proven. We've demonstrated that we can make new connections with these Nobel guys in Denver, and we know that it neuroprotects. I wrote a big justification to the patent office, and they approved the patent on 2 levels. They approved it because it has stuff that no one else has put in it, in a supplement, but they also approved it because the science that I quoted, and it's a long write-up, it is neuroprotective, and we know that it's neuroregenerative. So we know it works. We've now got it approved in Europe and in Ireland. We're working on Canada. So we know that it will do that. So that's the kind of stuff we want to study with the University of Houston Clear Lake and their brain trust over there. So that's what I wanted to talk to you about today.